Welcome back. Hope you found that Content Library Lab useful. We'll change gears here. In this lesson, we'll take a look at resource pools. We'll show you how to create a resource pool, set a resource pool attribute, describe expandable reservations, and describe scalable shares. So what are resource pools? It's a way to centrally manage resources in a hierarchical fashion. Resource pools are objects or logical components that can be assigned to either standalone ESX servers or, more likely, in a cluster. As we see in our picture here, these resource pools are hierarchical child objects in the vSphere inventory, where these resource pools are child objects to their parent. In this particular example, these resource pools are child objects to a standalone host. They could be, and more likely, are child objects to a cluster. Now, with resource pools, they basically are going to be a subset of resources drawn from a parent pool, such as either a standalone host or the cluster. Those top-level resource pool items are called root resource pools. They basically represent the hardware. So a standalone host with 8 gigs of memory has a root resource pool of 8 gigs of memory. A cluster of, say, 4 hosts of 8 gigs of memory each has a cluster root resource pool of 24 gigabytes of memory. In fact, once you've created a DRS cluster, you can no longer create host-based resource pools. So it's either going to be at the standalone host level or at a DRS cluster level, and you can't have both at the same time. But what this allows for is this hierarchical way to manage your resources that truly separates the resources from their hardware. Where that if I had a host that has, say, for instance, 8 gigabytes of memory, I could create one pool of, say, 4 gigabytes of memory, and another pool, the RPQA pool, of also 4 gigabytes of memory. So they now have 2 sets of resources that have been separated out from the root resource pool. And you end up having resources that are basically shared within the pool. So these VMs are going to share the 4 gigabytes of memory of their parent pool, and these VMs would actually share the resources within their parent. So you'll notice that you can even nest resource pools if you like. But there's isolation across the pools. So resource pool settings are a lot like when you have a VM with its traditional CPU memory settings. You can set CPU shares, reservations, limits. You can set memory shares, reservations, and limits. A little bit different because if you know your VM CPU and memory settings, the CPU shares on a VM are 1,000 shares per virtual CPU. For a resource pool, it defaults for 4,000 shares as the normal setting. That basically making the assumption that there are probably going to be 4 virtual CPUs in that resource pool. With memory, it's going to be by default 1,063,000 shares. Basically the assumption that you probably have, again, about 16 gigs of memory in a resource pool to start off with, right? Now again, these aren't numbers that represent the actual resources themselves. Shares are all about how they are related to the shares in sibling pools. But that's where the numbers come from. You can set reservations in a pool. Reservations in a pool are basically resources that are guaranteed to their child objects. And where we use them is when a VM has a reservation itself. The VM's reservations will draw from their parent pool's reservations. Now, reasons for resource pools, right? Things I've already mentioned. It's a flexible hierarchical organization. You can add, you can remove, you can reorganize your resources and adjust your resource allocations as needed. There's isolation between the pools and sharing in the pools. Those top-level administrators can make resources available to department-level administrators. You can even set permissions differently in the resource pool. So you can have somebody as a pool administrator, essentially, whose responsibility is to distribute the resources in their pool to their child objects. You have the separation of resources from the hardware, like we already mentioned. If you use DRS clusters, the resources of all the hosts will always be assigned to the cluster, right? And again, they're going to be designed when you have a cluster resource pool. You've got a multi-level of resource management. You have the cluster level of how the resources are going to be distributed around the cluster. Then DRS will inform the ESX servers how much of the resources inside each of the different pools are actually available at the host level. So then the hosts are going to be able to schedule with what resources they've been granted. This creates a scenario for when you need a multi-tier service model. So let's look at an example. Here we have a scenario where we have some root pool. Say this is a cluster doesn't really matter how many resources are in there. We notice that there's a pool called engineering who has basically been set with 4,000 shares, which is its default. It has a reservation of 1,000 megahertz and it has a limit of 4,000 megahertz. So the important thing here is the limit. That's the most that all of their child objects can consume at any one time. And you'll notice that the two VMs are actually both set to a limit of 4,000 megahertz as well. They can't both use 4,000 megahertz at the same time because their parent pool has been limited to 4,000 megahertz. If by chance they try to, you'll notice some other things that are going to be in play here. The engineering test VM has 1,000 shares. The engineering prod VM has 2,000 shares. So while they can't both consume 4,000 megahertz at the same time, if they try, they aren't going to compete equally, are they? The engineering prod VM is going to basically get twice the priority of those 4,000 megahertz over the engineering test VM. The engineering prod VM will actually get 250 megahertz first without any competition. And then what remains, the 3,750 megahertz, is where the two VMs will be competing. And amongst those 3,750 megahertz, basically the prod VM will get 2/3 of that, and the engineering test VM will get just 1/3 of that. But pools don't usually exist in isolation like this. Usually pools exist where there's more than one, so that they actually are siblings with each other. So here we have a set of pools, engineering and finance. We see that engineering has the default of 4,000 shares. The finance has been set to 8,000 shares. So finance has twice the priority over CPU share, or sorry, over the engineering pool when there's contention. Because remember, shares only take place when there's contention. Meanwhile, in those pools, the different VMs are also prioritized a bit differently. You have the engineering test and engineering prod. We see that the eng prod has 2,000 CPU shares and the engineering test has 1,000 shares. Same applies to the fin prod and fin test over on the finance pool. The fin prod has 2,000 shares and the fin test has 1,000 shares. So we can see that the prod VMs will have a 2-to-1 favoritism over the test VMs. But the two prod VMs, the eng prod and the fin prod, they don't compete equally, do they? Because their parents aren't the same. So basically, these are ratios of ratios. In fact, we break it down here and demonstrate that how this really is to be implemented. If you were to just think about what the root pool is, whatever size that is, the finance pool will be getting 67% of whatever the resources are when there's contention for them. And the engineering pool will be getting 33%, right? Exactly a 2-to-1 difference. And then within those pools, you have the engineering supplying 33% and his VMs. Well, we can see that the engineering test VM will be giving 11%. Then engineering prod VM would be granted 22%. This, of course, would only apply when all four VMs are all trying to compete for CPU. This is how it's going to break down. There's 2-to-1 within engineering. There's 2-to-1 within finance. And then there's 2-to-1 across finance to engineering. So that the poor old engineering test VM will be only able to get 11% when there's contention. Meanwhile, the fin prod will be getting 45%, right? It's basically how this is calculated is that, well, the fin prod is 2/3 and the fin test is 1/3 of their parent. Well, the parent has 2/3 compared to the 1/3 of his sibling. So this is really 2/3 of 2/3, which is where we get the 4/9, right? Or 45%, give or take, right? Whereas the engineering test, he's got 1/3 of 2/3. I'm sorry. He has 1/3 of 1/3 of the entire environment. So that's 1/3 of 1/3. That's 1/9, or as we show here, 11%. So you have this ratios of ratios breaking down this concept of a hierarchical way of doing resource management. So this is one approach. We'll take a look at other attributes when it comes to these resource pools in our next section. So stay tuned while we take a quick break.